So what is an ANOVA table? There's a few elements of an ANOVA table that we want to look at, because when we're doing an ANOVA, we're really saying we're going to create an ANOVA table, and we use that ANOVA table to take our conclusions. So ANOVA tables are broken down by source. So generally, each row in an ANOVA table is going to be a different source. And the sources, there's one for each treatment or factor, and the error, and the total variation. So each source has these next 5 associated with it: a degrees of freedom for the variation source, a sum of squares, a mean squares, and then 2 of the ones that we use to actually assess significance are the F statistic and p-value associated with that F statistic. So what sources are we evaluating in a one-way ANOVA? Well, we have between, error, and total. And between evaluates the significance of between group variation. It's important to note that it does not separate out the treatment levels and can only be used to determine if there's a significant difference between one or more. So no matter how many different, like let's say you're testing temperature, no matter how many different temperature levels that you assess, you're only, in an ANOVA, you're only going to get one between value. And all that tells you is that one or more of the groups is significantly different from one or more others. So, for example, let's say you test 10 temperature levels, and 9 of them are not significantly different, but one of them is from any of the others. Then you would see that there is a significant difference. And that goes the same if all 10 are significantly different from each other. So all it tells you is that there is a significant difference with one of those treatment groups, and we need to do further testing. And we'll get into that in a little bit. Error represents the variation due to the error between the regression model and the empirical results. Now, in certain special ANOVA cases, such as the two-way gauge R&R, error is the repeatability. So it's different ANOVAs do different things. They all have the same math, but how you use them is different based on what you're really looking at. And that's a really important thing about ANOVA is you really need to understand what you're doing, what you're looking into, to know what the results mean. And we'll get into that too. And total just represents the entire variation of the model. That includes both the between and the error variance to give you a good idea of how much variance is in this entire experiment.